Mrs. M. Priyadarshini, ME MBA, is doing PhD, is currently working as teaching fellow in the Department of IST, Anna University, Chennai. She completed a Master's in Software Engineering from Anna University. She has about 10 years of experience in handling courses for UG and PG. She was serving as Technical Evangelist for Corporate over 4 years in Java Enterprise Technologies, Software Engineering, Databases, AWT, and Design Patterns. She is proficient in handling IT projects as well into concept development for enterprises. She is doing a research in the area of web services security. Her other areas of interest include software engineering, AWT, databases, enterprise technologies, and service-oriented architecture. She holds many journal publications and conference proceedings in her research area.
Welcome to UGC lecture series in Computer Science Java part 24. So in this session we are going to see about border layout, card layout, grid bag layout and few demo programs based on these layouts. Previous session we have seen what is the use of layout manager, why do we go in for layout manager, and then we have seen layouts such as your flow layout, and then in this session we are going to see about border layout. So here border layout is nothing but arranging and resizing components to set in 5 positions. So you can place your components in north position, south, west, east and center. So whenever you are trying to place your components on the container, so already we have seen that all the components will be placed on the container. Container is again a component and the container can also be placed on another container. So now whenever I try to place the component, whenever I try to add the component, organizing these components is done using the help of layout manager. We have seen already few layouts, whereas here in this, with this help of your border layout, you can place all the components with respect to the 5 positions, whereas your components could also be containers. So I can have containers placed in all the positions. Even on the containers I can have a border layout and then I can place a set of components. So here you can see that components starts at their preferred size but are expanded as needed to fill the region they are in. So it means that whenever I try to add the components on the border layout, initially the size of the components will be organized based on the position that you add, and when you keep on expanding your layout, so the component size gets changed based on the place where you have placed that particular component, that is the position where you have placed that particular component. So you can add at most one component to each region of the border layout. To put more than one components in a section, put them in a panel with its own layout, then add the panel to the border layout. To start up with, whenever I add elements, whenever I add the components on a container, so I can put based on the positions. In one position I can add one particular component. Instead of adding one particular components, that is the base components, even I can add a container. So in the set of containers I can have various layouts being created. So for example, I have a container called panel. So on the panel I can have another layout such as flow layout or my grid layout. I can create those containers and then these containers can be added as components on the frame. So though that frame could be of type border layout. So the frame can follow border layout and the panel which is placed inside that particular frame can follow any layout as such your flow layout or your grid layout. The size of a region is adjusted depending on what is in it. So it means that whenever I am trying to add components on any of these positions, so I told you that north, south, east, west and center. So if any of the positions I am not adding any element, so in that case that particular size of that is the width and height becomes 0. So if there is nothing in a region, its size will be reduced to 0. So components in the north and south cells are stretched horizontally and those in the east and west are stretched vertically to fill in all the space. So your north and south of the border layout will always be stretched horizontally, whereas your east and your west will be stretched vertically. So whenever I add the components, those components will fit in into this particular horizontal and vertical, and whenever it is being resized, it will resize according to where it is being placed. So, the center is stretched vertically and horizontally as needed. So, it is a good place to put graphics or text area that you want to expand. So, the center you can place the components which could be stretched in whatever fashion you like, it may be horizontally or it may be vertically. So, normally text contents, graphic contents which occupies more space will be placed inside the center of the border layout. So, when you add components to a container which uses border layout, specify the target region as second parameter, as for example border layout dot north south. So, that is the position where you have to place that particular component. So, to prevent component resizing, add a component to panel with the flow layout, then add that panel to the border layout. So, I already told you that whenever you add the components, based on the components, that particular size of that region will be. So, for example, I have two components in my northern region and then I have two components in my southern region. So, whenever I say two components, it means that I would have created a panel and then I would have placed those components inside. So, whereas in the other areas, if I have directly placed one component, so the restretching, that is the resizing of the component takes place based on the layout that you have followed inside a panel. Provided I have followed a flow layout inside a panel, and then whenever I try to stretch, that particular panel will get stretched, whereas the components inside the panel will not get stretched. Flow layout panel will stretch, but the components will not stretch. If nothing has been added to a region, the neighboring regions expand to fill that space. So, already told you, whenever we do not have any components in one particular region, so the size of that width and height will be 0. So, what happens? So, the components that is available in the horizontal or vertical positions will occupy this particular place automatically. If you do not need any space between the regions, use the default constructor. You can also specify the number of pixels between the regions. So, whenever we place the components on the border layout, in all the 5 positions, components will be added without any space between the each and every component. So, the component in the north, component in the center, both will not have any space between. Similarly, the components in all the regions, they will be placed in such a way that they do not have any space. So, if at all I use a default constructor, it will not have any space between them, whereas if I use a constructor which specifies how much pixel need to be there in between the two regions, so I can even specify that using a different constructor. So, you can see that. So, I have p dot set layout, new border layout. So, I am creating a border layout. Here we have not specified anything. So, what happens? This will create a border layout without any spacing between the regions, whereas here we have p dot set layout, and then I am constructing the border layout using horizontal gap and the vertical gap. HGAP and VGAP are the distances in the pixel between the regions. Already we have seen that few components will be arranged vertically and few components will be stretched horizontally. So, based on that, your horizontal and vertical gap will be added between those particular components that is available in those regions. So, here we have a sample program. So, you can see here we have AWT package and then we have AWT.event package. So, and then here we create a frame. So, this frame, constructor of the frame, we have given the name of the frame and then we have created a panel. So, now I am adding the panel over to the frame. So, the frame will be added with the panel and then I am trying to set the layout for the panel. So, here you can see I am setting the layout to be border layout. So, then I am trying to add a button. So, name of the button I have given in the constructor of the button and then I have specified the second parameter, the region in which my button need to be placed. So, here we can see that there is only one button component that is added in the north, and then next we have another button named as south and it is added in the southern region of the border layout, and next we have east and then a button named west and then a button named center. So, here I have a border layout without any argument. So, it means that all these components will be placed without any space between them. Here I set the size of the frame to be 300 and then set my frame to be visible. So, here according to the size of the frame, the size of the components will reside. So, each region will occupy a particular space. Whenever I try to increase or resize my particular frame, so then automatically my border layout will get expanded and the components will get expanded horizontally and vertically. So, since one component is there in that particular region, so all the components will be stretched as such with respect to the size of the frame. So, you can see that once you run this program, we have a frame and then we have created all the regions, provided if you have not created a button in the western region. So, automatically your center, that is which is stretched horizontally, will occupy the entire space. So, your center will occupy the space which has been now given for region west. So, similarly, if I am trying to skip southern side, so then these west, center and east will automatically stretch towards this particular southern region. So, it means that automatically the resizing of the particular region happens, provided if we miss out any of these particular regions. So, next is your card layout. So, with respect to your border layout, the limitation is based on the regions you can specify the components and you can place, provided you can have many particular layouts being set in various regions. So, here in case of your card layout, so this card layout class manages 2 or more components. So, usually panel instances that share the same display space. So, it means that I have 2 panels. So, 2 panels are going to share the same display space. So, I can switch between the panels. So, this is similar to that of your tabbed pane. So, when using the card layout class, let the user choose between the components by using a combo box. So, what you can do is you can have a particular component based on the value that is available in the component, you can switch between the panels. So, each panel is said as a card. So, I have a deck of cards. So, similar to that I have a list of panels. So, one panel could only be displayed at one particular point of time, other panels will not be displayed on that particular, because all of them are going to share the same display area. So, another way to accomplish the same task is to use tabbed pane. So, a tabbed pane provides its own GUI using a tabbed pane is simpler than your card layout class, because whenever you consider a tabbed pane, you create the panel itself in form of tabs. So, I can have various display areas, various components, and then I can switch over between the tabs. So, I can view what is the next tab that is available and then I can switch over, whereas in case of card I can use any one of the component that is available in the frame and then I have to switch between my card. So, at one particular point of time I will not be able to visualize what are all the other panels that is available in the particular, I mean the other cards that are available in the card layout. So, each component that a card layout manages is like a playing card or a trading card in the stack, where only one top card is visible at any point of time. So, already we have seen that. So, card can be chosen in any of the following ways. One is by asking for either the first or last card in the order in which it was added to the container. So, here this is I can choose this card which I need to display based on any one of the way. First one is I can say the first card or the last card based on how it has been added. So, it is like a stack. So, whenever I add the element, I add it in the whenever I add it in the first, so then I will be always able to visible the first card, whereas if it is added the last, so the last of my card will be displayed. So, next is by flipping through the deck backwards and forwards. So, even I can flip the card. So, first card will be flipped with the other card and then the last card could be flipped with the other card. So, similarly I can flip between the cards and then by specifying a card with a specific name. So, even I can give the card name, I can create many cards and give individual card names and then just I can give the card name and then I can try to show that particular card. So, show is the method which is used in order to show or make a particular card visible. So, these are constructors. So, card layout creates a card layout 0 horizontal and vertical gap. Card layout, here even you can have horizontal and vertical gap between your cards. So, I have a deck of cards, even I have small space between the particular cards. So, here, so these are all the various ways in which you can load your particular card. I can give, it is used to flip the next card of the given container. On a particular container we place all these cards. So, I told you that I have a frame. So, frame is a container. On a frame we place various panels. So, next is public void previous. So, here this will flip to the previous card of the given container. Next is first method. So, this is used to flip the first card of the given container. So, now we will have a short break and then we will try to continue with the card layout further with the sample programs. Welcome back. So, in the previous session we are seeing about the card layout and various methods in the card layout. We will continue with that. So, here we have seen methods such as next, previous and first method, which is used in order to flip your cards between your various cards that is available in the layout. So next we have a method called last. It's used to flip the last card of the given container. So next is our show method. So this is the method which is used in order to show or make a particular card visible. So you can see the container, the parent, and then the string name. So this is used to flip the specified card with the given name. So we have already seen that we have many methods in order to switch between your cards. So one among them is directly we can specify a card name and then we can move on to that particular card. So show method will make a particular card visible. So we will see how to create a card layout. So initially we have to create a panel. So here we can keep the name of the panel to be cards. So in order to represent, there are various cards in that particular panel. So next we create a choice menu to switch between the cards. So we can have a choice menu, you can create a choice menu. On choosing a particular choice in the choice menu, you can switch between your cards. So next is create two panels, one with a set of buttons, other with text field. So two panels are created, one panel with a set of buttons and the other panel with a text field. So it means that we are differentiating the panels. So one panel with all buttons and the other panel with the text field. So here we can switch between the panels which has buttons or the panel which has the text field. So we have a set of cards. So that's why we have named the panel with the name cards. So now it means that the panel has set of cards. So in the same display area, I am going to display the panel with the buttons or with the text field. So here set layout of the panel cards to card layout. So now after creation of the panel named cards, I am trying to set the layout of that particular panel to be the card layout. So next add two panels in the card layout. So we can add that panel. So I am instantiating a card layout and then adding the panels inside the card layout. So now both of my panels has been added in the card layout. So I have three panels here. One panel is the initial panel for which I have given the name called cards, and then I have two more panels. One panel is filled with all buttons and the other panel is filled with the text field. So now I am trying to add these two panels in the card layout, that is the panel of buttons and the panel of text field to the card layout, and then after that add the choice menu. So this choice menu is added to the first panel, that is your panel which does not have the name card. So next write the listener for the choice menu. So now I need to write the listener for the choice menu such a way that on click of the particular option called buttons, so I will be displayed with the panel, that is the card with all buttons, and then on choosing a text field, so the card with the particular text field will be displayed in that particular display area. Now after writing the listener, show the panel in the cards based on the item selected in the choice menu. You can see here we have two card layouts. So card with buttons, so once we choose the button, so we have three buttons here, and then we choose the text field, we have the text field being displayed. So based on the value you choose on the particular choice menu, any one of these particular card will be displayed to the user. So this is how your card layout will be designed. So this is, I think this, you can see the similarity between this and your tabbed pane. So tabbed pane, you have various tabs. So even if you have going for system and properties, you have various tabs in which you select one particular tab. At particular point of time, the contents of that particular tab will be displayed to the user. Similar to that, you can use this card layout as one of the layout. Next is our grid bag layout. So grid bag layout is one of the most flexible and complex layout manager the Java platform provides. In your grid bag layout, you can place the components in a grid of rows and columns, allowing specified component to span multiple rows or columns. So you can see in your grid layout, your rows and columns are fixed. Whereas in case of your grid bag layout, you can fix up the number of rows and columns, and then you can make your particular component to span between rows and columns. So for example, I can have one component which could occupy two rows, and I can have one component which could occupy two columns even. So which is not possible in your grid layout. So in your grid layout, it's just rows and columns. Each cell, that is one particular rows, one particular column, could only be filled with one particular component. Whereas here I can choose where my component should start until where my component should proceed. all rows necessarily have the same height. Similarly, not all columns necessarily have the same width. So here whenever I organize the grid also, the grid, so in case of your grid layout, you will have equally distributed height and width for all your rows and columns, whereas it is not necessary here. So one column I can extend to a particular height and another column I can fix up another particular height. So you can see here, essentially grid bag layout places components in the rectangles in a grid and then uses the components preferred sizes to determine how big the cell should be. So the size of your cell depends on the components that you try to place on it. Each component managed by a grid bag layout is associated with an instance of the grid bag constraints that specifies how the component is laid out within the display area. So here we do not have any common mechanism in order to add the components on your grid bag layout. So what we do is we create an instance of the grid bag constraints. So I set up constraints for each and every component that I place on the grid bag layout. So in using this I can place the component wherever I like in whatever fashion, and I can organize it in any way. So I can have a combination of all types of layout in one particular using one particular grid bag layout. So what I need to do is I have to create the constraints, and based on the constraints I add the components on my grid bag. So you know that bag is nothing but a data structure which could hold the other components. So here using this grid bag we split that particular bag which is going to contain your components in form of grids. So you can see these are all the various parameters based on which you construct the constraints. So one is grid X and grid Y. So this grid X and grid Y specifies the position of the components display area, where the upper leftmost cell has address grid X is equal to 0 and grid Y is equal to 0. So whenever I have one particular component with this grid X value to be 0 and grid Y value to be 0, so it means that this component will be placed in the leftmost corner of your particular container. So here this grid X and grid Y gives you X and Y position of the component that need to be placed in that particular display area. So you can see here grid bag constraints are relative. This is default value. This specifies that the component is just placed just to the right of for grid X or just below the grid Y, the component that was added to the container just before this component was added. So I have added one component and then I am trying to add another component. So instead of specifying the proper grid X and grid Y positions, what I can do is just I can give my grid bag constraints dot relative. So this what this relative will do is, once if I am placing that in the row, it will place in the grid X position, and then if I set that particular property to be for the grid Y value, so then automatically this will be placed next to the column. So it means that grid X means it will place in the next to that of the component that is previously added. So next to that, in the sense next to column of that. Whenever I say it is in grid Y, so it means that next row of the component that is already been added. After that, this particular component will get added up. So I can specify the grid X value, grid Y value to be 0, 1, 1, 2, etc. based on the grid, or else even I can specify that to be relative. Here you can see that I can set up my grid width and grid height also. So this specifies the number of cells in a row. So for the grid width, so number of cells in a particular row or column, so it means that grid height. So the default value is 1 here, whereas I can say grid bag constraints dot reminder is used to specify the component to be placed last in its row or column. So here whenever I say grid width, so width is your x axis. So and then I specify my grid bag constraints dot reminder. So already I would have added a component, or I may not have added the component, but whenever I place this component, it will be placed at the remainder of that particular row. It means that it is added at the last of the row that you are trying to add now. And then if I say relative, so this is nothing but specify the component to be next to the last one in its row or the column. So I place that before my last element. So whenever I say reminder, it is the last element. Whenever I say it is relative, it will be before that of the last element. So if at all I have more number of elements, so it will get added as such. If I have only 1 or 2 components, so then if I say relative, so relative will always make you to add that in the first position, and then your reminder will make that to add in the next position. You have a variable fill. So here this is used when the components display area is larger than the components requested size to determine whether or how to resize the component. So whenever I am trying to resize the component, so I have one particular component and then I am trying to add that particular component and fix it in that particular grid. It can span row or it can span column. So the resizing happens based on your horizontal stretching or your vertical stretching. So based on that, even I can even horizontally and vertically stretch in order to resize the component. So fill is used in order to specify the constraints, whether this particular component in the display area does not accommodate, how to resize the particular component to fit into that area. So next is I have value called iPad X and iPad Y. So this specifies the component's internal padding within the layout. So inside my layout, how much my particular component is going to span as my internal padding. So similarly you have insets. So this specifies the external padding. So I have my layout, how much space I have between my component and the layout, whereas internal padding is going to specify what is the internal size of the particular component, whereas inset will specify how much your component is placed inside your particular layout. You can see minimum amount of space between the component and edges of its display area. So anchor is used when the component is smaller than its display area to determine whether to place the component. So it means that for my particular area in which I have to place my component. So I have a grid being specified, I mean cell being specified. So inside the cell I want to place a particular component, whereas the component size is very small and then I can place it anywhere. So I can place it to the left hand side top, that is the start position, the end position, bottom position. I can specify where exactly I need to anchor this item, that is place this item. So that could also be, I mean we also have lot of variables in order to specify where exactly this need to be fitted. So weight X and weight Y is used to determine how to distribute space, which is important for specifying the resizing behavior. So whenever I am trying to resize my frame, how my X values and Y values should be increased in order to accommodate the components is specified using weight X and weight Y. So you can see here a sample grid bag layout. So here we have 3 buttons in the first row, and in the second row I have only one particular button, and then in my third row has a button, whereas all these buttons are not sized for the entire cell. So here this button occupies 3 of your columns, whereas this button occupies 2 of your columns. So you can see how these could be organized in form of a grid bag layout. So you can consider your button 1. So before setting up the constraint, first we have to create a grid bag layout. So the grid bag layout is given as the parameter to your frame. So this code could be included inside a frame. So set layout, I am setting the layout of the frame to be grid bag layout, and then I am creating a grid bag constraint. I am trying to fill it. So inside fill I say grid bag constraint dot horizontal. So already we have seen what is the use of fill. So it is going to fill the components in the horizontal fashion. So next I am creating a button. So I have given the weight to be 0.5. This is used only whenever I resize, whereas here grid X and grid Y position is 0, 0. So you can see, and then I am trying to add the button with this particular constraints. You can see here this button. So this is 0, 0 position. So next is button 2. So here grid X is 1 and grid Y is 0. So I have not given any other constraint. Here you can see that this is your X position changes, but whereas your Y position does not change. So this is 1, this is 0, this is 1, and this is 2. So next is your button 3. So here my grid X value is 2 and grid Y is 0. So I have, since my index starts with 0, I have 3 components. So in that I am adding the button. Next is another button. So I have given the iPad Y is equal to 40. So this is going to internally pad the particular element with 40 pixel space. So you can see here we have weight X 0 and grid width I have given as 3. So it means that it occupies the 3 particular columns, and here we have grid X to be 0 and grid Y to be 1. So it means that this is in the second row, and then I am adding this. Again I am coming to button 5. So here I pad Y value is 0. So I have not padded anything, whereas I have given weight Y to be 1. So this is for my vertical space. So I am anchoring with page end. So you can see here this is at the end of the, so this is your display area. In the display area at the page end I am trying to have this component. Then I have to specify what is my X and y value. You can see here I am specifying my insets to be 10, 0, 0, 1. So, inset, this is the internal space that I give for that particular component inside that particular cell. So, here grid X is 1 and grid width is equal to 2 columns. So, you have seen that button 5 is of 2 columns and then grid Y, it is in the third row. So, and I am adding this particular button. So, the summary, in this session we have seen about border layout, and then we have seen about what is a card layout, and then we have seen what is grid bag layout, and then we have seen few samples of how to construct your various layouts. So, from this session you will be able to answer questions such as how are objects organized in the border layout. So, what is the significance of grid bag layout, how is card layout constructed. So, when multiple layouts need to be adopted in a container, how this is done. So, in your forthcoming sessions we are going to see about how you are going to handle your event. So, your event delegation model. Thank you.